Bismillahirrahmanirrahim. My name is Hamzah bin Alam and I will present about our project Taman Wirajaya of design water demand circulation, sewerage system and stormwater management. So this is our group 11. So the group member is me, Hamzah bin Alam, and Muhammad Nusyari bin Azhar and Ricky Chuk. Our lecturer is Dr. Muhammad Saleh bin Haji Ustan and TS Dr. Rosinda binti Sesoya. We are from section 1. So for the introduction for this project, the Taman Wirajaya is a residential area located in the town of Pariraja, Johor. This area is highly sought after due to its strategic location, as it is situated close to school. This proximity to educational institution is a major draw for both student and school staff, as it eliminates the need for long commutes and allow for more time to be spent on studies and work. So the residential area comprises of 30 semi-detached houses and is home to approximately 155 people. The main purpose of Taman Wirajaya Pariraja Johor housing is to provide a comfortable and convenient living space for local employers and students who reside in the Pariraja area. So the objective of our project is firstly to determine the size of the needed water tank for the residential area at Taman Wirajaya Pariraja Johor. And then to determine the size of a sewer pipe and design of sewerage system for a residential area in Taman Wirajaya Pariraja Johor. And the last one, to determine the stormwater management for a residential area in Taman Wirajaya Pariraja Johor.
Assalamualaikum, my name is Kijong. So I'm a part of the present about the case study area and the design for reticulation water tank. So first thing first, I would like to present about the case study area. The study area is at Taman Wirajaya Pariraja Johor. This is the picture from the Google map, and this is the picture for the house.
For methodology, this chapter look at the method how to design the water demand circulation, sewerage system and storm management at Taman Wirajaya. So it starts with the study strategy, data collecting, followed by computation to choose the best layout for the research location. This is the flow chart. The first one is selection and finding the case study location, and then data and information collection, and then evaluate and analysis data. So we have three that we need to find is water reticulation system, which is need to design the water tank, hydrant flow, flow rate and velocity of water supply, and design of elevator tank. For the water sewerage system, we propose of site of sewage treatment plant, area model and buffer zone, and then sewerage reticulation design. Then for stormwater management, we estimating big runoff, the rational method. And then the study team had obtained a number of report for review from various sources. This report include Akta Suruhanjaya Perkhidmatan Air Negara Act 2006, and then MWA Previous Work, MSMA MOSMA Second Edition, Hydrological Procedure Number 227, Volume 4 Hydrology and Water Resource, and the last one is for the Water Service Industry Act 2006. In order to improve the water supply and demand balance index, it is also necessary to reduce water demand. The reduction of agriculture, industrial, ecological and domestic water consumption. The sewerage system is designed to carry all the sewage flow, including sewage to the approved disposal point. Sewer pipe should not be constructed on slope or within slope failure envelope. So in the event where it is unavoidable, the said structure must be designed not to encounter settlement of the sort and any time at risk of collapse during its operating lifespan. So this the aim for stormwater management here is to prevent erosion of agriculture land and flooding of inhabited urban or rural areas. Both cases can cause severe damage and contamination of the environment if sanitation facilities are flooded. This results in high cost and notably massive suffering for the local communities. For the analysis and design of water sewerage system, we have designed 4 manhole, which is manhole 1 to manhole 2, manhole 2 to manhole 3, manhole 3 to manhole 4, and plus 1 is manhole 4 to sewerage apa namanya?
Alright, for the water demand estimation, basically the water demand there we get from the table, which is the type of house is single story terrace house, and the water demand is 1,300. We times with the number of house, which is 47, and we get 61,100 liter per day. So we add 10% loss, which is from the total 6,110, and we sum up all the losses and the subtotal, and we get the grand total, which is 67,210. Okay, next is water tank design. Basically, we follow the requirement from the span, which is the height we will assume as a 5 meter or 7 meter. So first thing first, we need to find the area, which is the formula is daily water demand divided by 5 meter, which is the height, and we get 13.44 meters square. And we find the length by square root the area, and we get the length is 3.67 meter. To find the base or the width, we use the formula, which is the volume formula, width times length times height, and we get the base, which is 3.67 meter. This is the water tank, volume of water tank. Right, for the next part is hydrant flow, which is the hydrant flow we get from the table of average total flow rate. Okay, this is the house is a class D risk because it's residential terrace house. So the average total flow is 1,140, equal to 19 liters per second. This is 1,140 is in minute, so we need to find the in second. Next step is we convert the total demand per day to the second, and we get 0.778 liter per second. So next is find the flow rate, which is the Q, the total flow rate, which is water demand in semi-detached plus the hydrant flow, and we get 19.008 liter per second. And the last step is to find the peak flow, which is 2.5 times average flow. Average flow is we get from the daily total demand per daily in second, and we get 1.945 liter per second. For the flow rate and velocity of water supply, the first step is we need to find the area of pipe, which is pi times r, which is radius square, and we get 0.018 meter per square. And the next step is we find the velocity, which is from the flow rate formula. We use V equal to Q divided by A, and we get 0.0432, and the maximum velocity in pipe is 0.7 meter per second. So this is usable velocity. Okay, the last part for my part is a design of elevated tank, which is the first step is by using the rules, which is the capacity of service tank should be 2 divided by 3 from the total water demand. So the volume of elevated tank, which is 2 divided by 3 times the total demand, and we get 0.907 meter cube. So for the assumption for the water tank is the width is 1.5 meter, length 0.8 meter, and the height 0.8 meter.
Assalamualaikum, and hi, I'm Muhammad Syahrin bin Azhar, and I will be presenting our project Stormwater Management, which is for the introduction. Firstly, it is the control of precipitation and snow melt that runs off surfaces, where like roof, streets, and parking lot is referred to as stormwater management. Next is stormwater management aims to lessen stormwater runoff's detrimental effects on the environment and nearby population, where this is often accomplished by combining physical structures such as underground storage tanks and retention ponds with non-substructural action like green roof and rain gardens. And lastly, it is depending on the local climate geography and type of development, which is different stormwater management strategies will be used. Next, we jump to the method that being used, which is the rational method, where before planning stormwater management, the value of the runoff peak flow must be established, which is a common technique for determining the peak discharge from a small drainage area is the rational method. This technique uses a straightforward mathematical formula to relate the drainage area, the runoff coefficient, and the intensity of the rainfall event to the peak runoff rate. Here is some assumption used in the rational method, which is first, the peak flow occurs when entire catchment is contributing to flow. Next, the rainfall intensity is uniform over entire catchment area. And lastly, the rainfall intensity is uniform over time duration equal to time centration, which is TC. This is the general procedure of rational method, which is first we select design ARI, which is ARI for the drainage system. Next is discretize subcatchment, where divide subcatchment into segment of homogeneous land use or surface slope. Next is estimate time of concentration, which is TC, where estimate overland flow time and estimate flow time for all other flow components within the subcatchment such as curb, gutter, pipe, and channels. After that, we determine the average rainfall intensity, which is I. We calculate I for design ARI and duration of equal to the time of concentration. And after that, we estimate runoff coefficient, where the estimate C values for each segment if they are different than use. Next, we calculate average runoff coefficient by using the equation 2.4 from MASMA. And lastly, we calculate peak flow rate, which is Q for the subcatchment. And we calculate peak flow rate from the equation 2.3. And here is the runoff peak calculation, which is first we select design ARI and type of area is new house and the ARI is 10 years and also the T value is 10, and after that the drainage area for this is 2.012 hectare. And after that we calculate the coefficient value and we get 0.74. And after that we calculate the TC value, which is we get 3.75 minute, and the TD value is 1.40 minute. The total for T is 5.15 minute. And after that we calculate the I value and we manage to get 238 and 90 mm per hour. After we get all the data, we put into the design flow equation, which we get 0.99 mm cube per second. And finally, for the conclusion, firstly, water reticulation system is crucial because it allows consumers in residential or business location to access clean water. Before putting this system into place, a number of things need to be taken into account, including the size of pump, the material employed, and the ideal location. This is significant because it may make system maintenance simpler and provide protection against harms like water leaks. Next, as a method of gathering and removing impurities from wastewater into the residential sewage system, the sewage system is also crucial for projects consumer because it allows them to drink clean water, and this reduced runoff from precipitation on the streets or many other areas can aid in stormwater management. Next, by completing this project, students will gain knowledge on how to build a water tank using MASMA, where the objective is to offer direction for planning and designing stormwater management system. Since the MASMA will help the engineer develop and improve water quality and quantity in the next year, it must be adhered to while designing the water demand.